Thank you. Can you hear me? It's good? OK. So I'm Valentina Mancinelli, and I'm a software engineer from CERN. And in the past 2 years, I've been working on the HammerCloud service that I'm going to describe today. I choose a very long title. So I'm going to give you an introduction of what is CERN and what is the WLCG for the ones who are not familiar with it. And then I'm going to describe you what is HammerCloud, what it does, and how it's used by the experiments to run stress and functional tests on the worldwide LHC computing grid resources. So what is CERN? CERN is a cool place. The coolest we can say, literally, is part of the LHC are cooled down to 2 Kelvin degrees. So that's the coldest temperature reached and measured in the universe. So CERN stands for the European Organization for Nuclear Research, and in French it works better, the acronym. And it is composed by 21 countries, and Czech Republic is one of them. And it's also CERN is also a laboratory, a physics laboratory, just outside Geneva, in the border from Switzerland and France. And its mission is to study the fundamental laws of physics. There are many experiments that are carried on at CERN, but probably the most famous one are the one connected to the LHC, the Large Hadron Collider. The Large Hadron Collider is the biggest collider in the world. It has 27 kilometers circumference. You can see the outline in the map in the countryside just outside Geneva. This is another picture representation. So the LHC is located 100 meters below the ground. And inside the LHC, a bunch of particles are accelerated up to 0.9999 times the speed of light, till the point when they perform more than 10,000 rounds around the 27 kilometers per second. I forgot to mention that so the LHC is used to study the high energy physics. And so there are 2 tracks around for bunch of particles around the LHC, and so that the bunch of particles run in opposite direction. And there are 4 points where this bunch can meet and where they collide. And on these 4 points is where the 4 experiments detectors are located. These are the pictures of the 4 detectors. The experiments are ALICE, ATLAS, CMS, and LSCB. To give an indication of the size, I hope you can see, this is a person standing in front of the detector of ATLAS, which is the biggest of the 4 detectors. It's bigger than a 4 stories building, and couldn't probably fit in this. It couldn't fit in this room. The 4 experiments have focused on different aspects of the physics that happen during the collision, but so they're different, but basically they're big cameras that take snapshot of what happened during the collision. They're constructed as layers of sensors, and this sensor measure different things that happen during the collision, like the passage of a particle through the sensor, or for example, measure the energy of the particle. So the data processing of the data collected by the LHC can be very much simplified like this. So in the LHC, the collision happened, and these snapshots are collected by the detector. Not all the events are collected. First, there are filters that remove the not interesting events. For example, the one with that happen in low energy that have been already studied in the past, so they're not interesting. The filters are both hardware and software. What comes out is, for example, something like this. This is a visual representation of a collision, of the events of a collision. This is actually very important because what was one of the one presented by the experiment CMS to prove the measurement of a production of Higgs boson. After this, the data is distributed all around the world so that physicists can access it and process it. Processing means, for example, changing the format, reducing the size of the data, and run statistical analysis on it and produce plot. And if from the statistical analysis you're lucky and you find something, then you write an article about it. So the data distribution and data processing all around the world is performed thanks to the WLCG, the Worldwide LHC Computing Grid. It's composed, the WLCG is composed by more than 170 data centers spread all around the world in 42 countries. The only continent where there is not a data center is Antarctica. And so it has a tier structure, and the tier 0 is CERN that acquire the data from the LHC, stores for long-term storage, and distribute it all over the world. All the data centers all around the world provide resources on the numbers of 300 petabytes of disk, 200 petabytes of tape, 300,000 cores. But all these resources come from a very heterogeneous environment. So there are high throughput, high performance, let's say, opportunistic resources, cloud resources, and and also use different kind of middleware, different kind of storage type. And the objective of the WLCG is to provide a transparent access to the physicists all around the world to access and process the data without caring about all the underlying differences and complexity. There is a community of more than 10,000 users of physicists that run their analysis in producing around 2 million of jobs every day. So as I said, the physicists are transparent over the complexity and the heterogeneity of the system, but what they care is that their data analysis is fast and is performant and it works. But with this complex system, you can understand that it's hard to monitor the performances, make changes, and evaluate the performances after the changes. And it was with this in mind that HammerCloud was created to give a tool to site administrator, system administrator, a way to run tests and when provisioning, for example, new data centers. HammerCloud is a service that provides the functionality of running tests on demand with the possibility to manage to generate on a site a desired load, so to run also large scale stress tests, but also for constant validation to automatically generate tests and for continuous test. An important point of HammerCloud is that to test the site is we use the real workload of the experiment. So we use the same, to test the site, we submit jobs, and these jobs are the same workload that the physicists submit to process their data. There are others, the WLCG use other monitoring tools and testing tools to test more basic functionalities of the components, for example, to test the read and write from storage. But this, using the real workload of the experiments can test all the workflow of the whole stack, from test submission to landing the job on the working node to accessing the data. So it tests everything. And also, HammerCloud provide real-time information about the results of the test with the efficiency of the jobs and the success rate and the performances of the jobs submitted with the tests. It's used by 3 experiments at CERN with different use cases. And in average, we manage around 100 tests per day. We produce a load of 100,000 jobs per day, which is more or less 2% of the total submit jobs. But if we see the real consumption CPU, it's a lot less, because usually these jobs are shorter, just to test the functionalities and the performances. So some concepts. So we use template to give the possibility to users to define a class of tests. Comparing with the object-oriented, this is exactly the definition of a class for the test, and this allow the users to define what kind of job they want to run, so that they can run the same jobs on every site. So perfectly be sure that what they submitted is the same on every site, and perfectly measure the performances of the whole stack on different sites, on different architecture. The test is, let's say, the instance of a template. It has a start time and end time, and it's the one that HammerCloud runs and derives the definition, the configuration from the template, and it during its run, it submits jobs. As I say, the job is the experiment payload that are submitted to the target site and run on the site. And the job results, by job results, we don't care about the actual output of the jobs. That would be the output of the data processing normally. What we care is about the performance of the job. So we use and we gather metrics about the execution of these jobs, and that's what we store and we use for the test report. So to give very simple view of the architecture, we have web interface that it's built with Django, where the user can configure templates and tests and request new tests, and also where we provide plots and statistics about the test results. Then there is the backend, the HammerCloud test infrastructure, that is the one that takes care of scheduling the tests, generating the jobs from the user configuration, and then submitting to the grid resources. The blue cloud, clouds will be a site on the grid, and the blocks are the single worker node inside the site. To submit to the resources of the WLCG, as we submit the same we use the same workflow of the experiments. We submit through the single experiments workload management system. There's Panda for Atlas, CRAB for CMS, and Dirac for HCB. And these workload management systems are the ones that take care of scheduling the jobs and submitting them and landing them on the actual working node. And to do so, we use a software developed in collaboration with CERN, that is Ganga, that gives a common interface for the different clients to use for the experiment-specific workload management system. So yeah, we use Ganga to submit the jobs, and HammerCloud monitor these jobs, and it takes care of resubmitting and to create on the site the desired load that the user requested, and gets from the workload management system we get the metrics of the job results, and we store it in our database, and then we create summaries and test report to show to the user. In particular, here you can see how the user can configure a template. You can choose if the category, if functional or stress test. The difference is that if it's functional, the user, and if it's active, HammerCloud will take care of resubmitting new tests continuously. So the user, once they create the template, doesn't have to do anything else, and they run till the template is active. If it's a stress test, the user configure the class of the template, and then we'll, with another, show you later, we'll request new tests. And yeah, the user also choose what kind of job they want to submit, as we said, so that they know which one, what kind of job, what kind are submitting, and then select the sites to target with this template, and how much jobs they want to, how much load they want to generate on these sites. As I know, the HammerCloud is aware of the topology of the grid, seen as the experiments as we pull the information from the topology grid information services of the experiments. After this. So for stress test, the user can just select which template to use and add start time and end time, and HammerCloud will schedule and run the new test. As I said, we have pages with report for the test to show how much load is on the resources, the evolution for the success rate, and also let's say more important, the plots over for the performances. So here, for example, there are how many events per second have been processed, CPU percentage, and these are what we use as metrics for. This is Atlas jobs. We give information not only at test level, but also a more generic view. For example, here there is on top the results for one specific site of a specific set of templates that are important for the experts for this site. So the results over the time of this particular template, and a view of the old grid. We're using colors to easily show the sites that are more performant and the ones that are less performant, so that for example, cloud admin or site admin can easily spot the issues. So HammerCloud has been used extensively by the experiments over the years, and has become an essential tool for tests and for automating, and it's been very useful for especially for the experiments computing operation, and it helps to reduce the effort for the operations, and is used for everyday, let's say everyday operation to generate report for site performance monitoring, or to as I show for to provide views for constant site efficiency monitoring. But it's also used for taking automatic actions. For example, in Atlas, HammerCloud use a set of very specific craft and define template to so use the results of these templates to blacklist or recover the sites. So this is the activity of HammerCloud blacklisting the Atlas sites over the various year. It's I think it's monthly. Yes, it's monthly. So this is all the decision that HammerCloud took based on the test results, and this is very important because before this was the job of operators that had to monitor the jobs over the old WLCG and check which one were failing, debug the reason why they were failing. If it was, for example, misconfiguration from the user, and then blacklist the site, contact the site admin, and this is all done automatically now with HammerCloud in the HammerCloud results. But it's also used for commissioning new system and technology. For example, it's used for testing the changes in the workflow management system when introducing new components or changing the components, so that the developers can request for test, configuring the job so that they go and test, for example, a dev version of the workflow management system and the components. It's been used also for commissioning for example, during the commission of the Wigner data centers, when CERN was extending the resources of the CERN data center to compare the performances of the Meran data center and the Wigner data center by running tests that, for example, were configured to read from data in one data center and then data from another data center and compare the performances. And it's also been used to run skill tests on the new CMS workflow management system, CRUB3, in 2004 and 2014, when getting ready for run 2 for the new run of the LHC. CMS upgraded their workflow management system to CRUB3, and he used HammerCloud to generate load on the system. So here we weren't targeting sites, but we were targeting the whole system basically. And you see in the picture these are the simultaneously running job. They managed to reach the goal that they were targeting of 20,000 jobs. It's both red, but if you can see, the dark red are the jobs submitted by HammerCloud, and the red, bright red, are the ones submitted by the user. And this was very useful for them because they could generate the desired load on the system without having to, for example, ask for campaign from the user, ask them to use the new system to scale testing. They could decide when the time period when to do it and how to increase the load. So they had all these. They had HammerCloud to do this for them. So I showed you how HammerCloud is important and how it's used for the operation of and the testing for in the WLCG. And in the past 2 years, we focused on strengthening the infrastructure. We moved to the CERN Agile infrastructure. We're very happy user of the CERN Agile infrastructure, which use the CERN private cloud powered by OpenStack. Use Puppet as configuration management for the host, and Foreman to map host to host group and sub-host group. And we use environment to separate the production clusters from the QA and dev clusters, and we use host group and sub-host group to identify the different kind of machines. We have about a little bit more than 20 virtual machines on Scientific Linux 6, and so yeah, we separate, for example, web server, the submission host, and separated with different configuration we do in the one used for each experiment. Yep. Also, coming from free with the agile infrastructure of CERN, there is also the tools developed by the CERN IT monitoring so we don't have to develop our own monitoring for our infrastructure. It comes for free, comes with the machines deployed on the CERN Agile infrastructure. We have host monitoring for all the machines of the infrastructure. A framework to develop custom sensors on the host in Python, way to configure notification, and also to report service level monitoring, and all this with a nice Kibana interface. So yeah, as I say, we try to improve our infrastructure, but of course there's always room for improvement. We're trying to improve our operations, especially the QA process, with increasing the use of unit tests and code review. We're thinking about introducing continuous integration that we're not using now, thinking about using Jenkins. We're also reviewing the HammerCloud data store and planning to move the monitoring of the test results to the ELK, the ELK stack. But there's not only plans for the infrastructure, there are also planning for extending the functionalities of HammerCloud. As I said, till now it was used. It was already used for commissioning new sites to test the infrastructure of the new site and evaluate the performances. And CERN is now planning how to extend the infrastructure. One of the possible roads is that they're taking into the consideration is to provision resources from a commercial cloud provider, and we like to provide a tool to test these resources without first of all without exposing the experiments directly to issues with infrastructure that can be discovered and fixed with this kind of tests, and also to have a tool to compare the performances of different providers. To do this, taking a look at the infrastructure again, we want to avoid to go through directly the workload management system, and we're thinking about using Conda to submit payload directly on the host of the resources of the provider. And this job submitted can be, for example, wrapped experiment payload that can run but without the workload management system, so we can test the resources really with what then the experiments will want to run on them, but also benchmark too for performance evaluation and comparison. And that was all. It was faster than I thought. Thank you for your attention. Any question? Yes.
So is HammerCloud open source? And if so, is the templating engine generic enough to be able to test like any kind of infrastructure if I create the template?
At the moment, so it's open source, but at the moment, let's say, since it was focused on submitting jobs for the workload management system, so jobs that were, for example, analysis jobs for Atlas, for CMS. So it was built around this idea. So that's what, and especially because it was using only Ganga as submit backend, let's say. So it would create jobs that are job configuration, and it's for Ganga. But since we're now we're planning to move with another with Condor. We're planning on having this totally a lot more generic. So a way to have from the template configuration generate something that is an executable and that can be shipped to a resource. Yes.
You mentioned that you are going to introduce continuous integration.
Sorry?
You are going to introduce CI.
Yes.
Does it mean that you are not using CI right?
So yes, that's it. So we don't have a continuous integration. We use the development cluster, QA cluster, but what we do is develop, then push the commit, build. We have a building system, but then it's more manual the way we put it to QA and then it goes in production. So that's a good, one of the wanted improvement that would really improve the process. Is that enough? Okay. There was yes.
You said you're actually stress testing with actual data from the experiments, right?
Yes.
So how are you doing this? Are you just submitting a cluster job and then checking if the results are correct as well?
We don't care about the result of the output, let's say, of the job. So if the
like a system fails and the result is therefore wrong, then it's probably an indicator as well, right?
The thing that we're checking is not really that the output is correct, because what we want to see is that the job could perform, could correctly perform. So we're checking that all the components in the stack were correctly working, so that the job could access the data, could run the software framework for the experiment, could write the data, could edit and then the data could be, the output data are put in the catalog. So all this more than, it's pretty much trusted the fact that if you submit a job that asks to do this, then the output should be always the same, but we don't check that.
Another question, do you track how much money it would actually cost to run HammerCloud, for example, really with a cloud provider? I've been working in HPC for a couple of years, and there's many projects that actually think about like how many resources do we use, how many energy, how much water cooling do we use, and what's the expenditure for the company, for CERN, for example.
Yeah, of course. I mean, you're actually using the CPU, so you're paying what you're doing. But the phase when we use it is when the integration team or the site administration want to be sure that the system, the resource and the architecture work. So it's maybe. So this wouldn't be used when you can actually run real jobs. So before you want to be sure that you want to put these resources inside the grid. Before putting real, for example, before having the real user physicists submit to those resources and then having job failing because there was issue that we could have spotted before with this. So of course it's money, but it's also this is important to have your user happy. Yes. Yeah.
Could you point us to the page with the source code? I'm trying to Google that, but I'm not able to find the page with the actual code, just some results from Atlas CMS.
Yes, I will check to be sure which one, and then we can see later. Yes.
So you perform stress tests only before having production systems being used.
Usually, yes.
But do you ever do some performance regression testing?
Somewhat.
Performance regression testing. Like, do you test whether the performance gets lower in time?
While in production, while this resource is in production. Not really. I mean, we used no. We haven't been for the moment. It wasn't used like this.
The idea is that you run stuff on the production systems. At a certain point, HammerCloud blacklists the node, and you check whether you can fix it.
For that is for the continuous checks we don't really stress test the system. We just use small simple sample jobs that check the full stack, the full workflow, and but don't take a lot of CPU and don't stress the system because it's production, doesn't stress the site because it's on production. We just want to make sure that if things are working, keeps working. If things are not working, we spot the problem. It gets blacklisted, notify the site, and the site can act on it. And then if it goes back let's say when blacklisted, they go in test, so the site can perform their intervention. And if HammerCloud keeps sending jobs, and if then the jobs are successful, then they come back online. Yes.
Does this test include also testing the scheduler like Panda? So if you deploy a new version of Panda, are you able to discover that there is some more bug or regression in Panda that, for example, scheduling is not done in an optimized way, or it does only monitoring of the infrastructure itself if it performs good?
It was just for performance of the whole workload management system with CRAB, like I showed you before with the scale test. This slide. So here it was mainly used just to. So in this part it was used as a submission, a stress test tool. So to generate a lot of load, and then from the CRAB tree side, they were measuring the performance with their own tools, and was basically HammerCloud was used to stress test it. In general, when making new changes, what the user does is to request the developer is, for example, when making changes to a component of the workload management system of Panda, for example, the data mover or this kind of components, they request a test specific to test that part, but not performance. I'm out of time. If you want to keep talking about this, we can do it. Okay. Thank you.